Hello, good people. This is section 3.1. We're still with the chain rule, but we're doing part two. So, just to recap, the chain rule is a shortcut for situations where we have a composition of functions, meaning that there's an inner and an outer function, right? So, something like this: if y equals the sine of, let's say, 1 over x. I have an inner function and I have an outer function. And so what we said was identify the inside function. We're going to call that u. And then take the derivative of u. I'm just going to call it u prime. Now, in order to take this derivative, I have to set up a product rule. That's not true. In order to do this derivative, I have to set up a power rule, which would make it look like this. And then I can take the power rule derivative fairly easily, right? You multiply the exponent times the coefficient, x to the power of, take 1 away from the original power, and you're left with this. So this is the derivative of 1 over x, negative 1 over x squared. And so then we said that if you think about it, y is the sine of the inside function, which we're calling u. So therefore, the derivative of y, or dy dx, is the derivative of the outside, which is cosine, with the inside still in it, times the derivative of the inside. So that was a chain rule. And then since we had already identified the u inner function and the u prime, the derivative of the inner function, then we could say pretty confidently that the derivative is cosine of 1 over x times negative 1 over x squared. And I would leave it like that. Some people might say negative cosine of 1 over x divided by x squared. I guess that's another way to write it, but either one of these would be correct. But the idea is pretty straightforward. If you have an inner and outer function, we take the derivative of the outer function, which was cosine, with the inside function, the inner function still in there, times the derivative of the inner function, which is u prime. And so it's called the chain rule because if there are multiple compositions, if there are multiple inner functions, then at every step, I'm just going to multiply by the derivative of the inside, multiply by the derivative of the inside, multiply by the derivative of the inside, and therefore creating a chain of derivatives. And that's what this first part of this video is going to tell us here. That what happens if we have multiple chain rules. For example, I'm going to start with letter B, and then in the next video, I'll do A and C. So letter B says, what if we have a function called g of x that is an exponential function? So e to the power of. But my power is another composition. So cosine of 2x could be identified as my u. But when I write this, I realize there's an inner and outer function dynamic here, right? There's an inner function and then there's an outer function. So when I do u prime, or the derivative of this, I'm going to have to take the derivative of the outside with the inside still in it times the derivative of the inside. So the derivative of cosine, which is negative sine, with the inside still in it, times the derivative of the inside, the derivative of 2x, which is 2. Now notice, we haven't even taken the derivative of g of x yet. That's just the derivative of my inner function that was inside of the exponential. So now when I go back and say g prime, well, let's call it g of x, is e to the u, well, then we know that g prime of x is e to the u times u prime. But when I did u prime, I also had to do a chain rule. And so my final answer here is u to the cosine of 2x times negative sine 2x times 2. So there were 3 different functions going on here. I had the exponential e to the something, I had the trig cosine of something, and then I had the 2x, which was like the innermost function. So 2x is inside of cosine x, and all of that is inside of the exponential. So notice that I ended up with 1, 2, 3 terms that I'm multiplying, and thus creating a chain of derivatives, because I started with the derivative of the outer with the inside still in it times the derivative of the inside times the derivative of the inside. And that's how I create this chain of terms that are being multiplied. Now, it really isn't much to simplify here. I guess you could say negative 2e to the cosine 2x times sine 2x, I guess. But there really isn't much you can simplify there. But the moral of the story is we can have multiple compositions or multiple functions being composed, in which case we're going to have to stretch out and continue to perform the chain rule in multiple steps. So in video 2, we're going to look at setup A, function A, and then we'll look at function C here before we get into the other way that the chain rule can appear in a differentiation problem.